The dream of free limitless energy has captivated inventors, scientists, and everyday people for centuries. Imagine a world where you could break free from soaring electricity bills and unreliable power grids. The allure of harnessing energy from unconventional sources has led to countless experiments, some successful, many dubious. Among these, the concept of a Magmo generator has gained traction in DIY energy circles, promising a revolutionary way to power homes. Skeptics dismiss it as pseudoscience, while enthusiasts swear by its potential to disrupt traditional energy systems. This video dives deep into the reality of building a DIY Magmo generator, testing its capabilities, and analyzing whether it can truly power a home. We'll explore the materials needed, the step-by-step construction process, and the challenges of making it work reliably. By the end, you'll have a clear understanding of whether this device is a viable energy solution or just another overhyped experiment. The journey begins with gathering the necessary components, many of which can be found in hardware stores or even lying around the house. A sturdy base, such as a wooden board or plastic platform, is essential to mount the generator's components securely. Copper wire, magnets, and a rotating mechanism form the core of the Magmo generator's energy-producing system. You'll also need a small DC motor, which acts as the initial power source to kickstart the generator's motion. Neodymium magnets are preferred for their strong magnetic fields, which are crucial for generating significant electrical output. A series of bearings and axles ensure smooth rotation, reducing friction that could hinder the generator's efficiency. Basic tools like screwdrivers, pliers, and a soldering iron are necessary for assembling the components into a functional unit. Safety gear, including gloves and goggles, should never be overlooked. Working with magnets and electricity carries risks. Once all materials are ready, the construction process begins with mounting the motor onto the base. The motor's shaft is connected to a rotor, which holds the magnets in a carefully spaced arrangement. Copper coils are wound around a non-conductive core and positioned close enough to the magnets to induce an electromagnetic field. Proper alignment is critical. Misplaced coils or unevenly spaced magnets will drastically reduce power output. The rotor must spin freely, so ensuring the bearings are well lubricated and securely fastened is a key step. Wiring the coils to a rectifier converts the alternating current, AC, produced into direct currents, DC, which is more usable for small devices. A capacitor helps stabilize the current, preventing surges that could damage connected electronics. Finally, an output terminal allows you to connect the generator to a battery or small appliance for testing. With the assembly complete, it's time to put the Magmo generator to the test and see if it lives up to the hype. The initial spin of the rotor should produce a small voltage, detectable with a multimeter. If nothing happens, double-check all connections and ensure the magnets and coils are properly aligned. Friction is the enemy. Any resistance in the rotor's movement will diminish the generator's efficiency. Once operational, measuring the output reveals whether the device can produce meaningful power. In most DIY setups, the Magmo generator generates only a few watts, enough to light an LED but far from powering a home. Scaling up the design with larger coils and more powerful magnets could increase output, but space and cost become limiting factors. Even in optimal conditions, the generator struggles to maintain consistent power without an external energy source. This raises the critical question: is the Magmo generator truly self-sustaining, or does it rely on perpetual motionness? The laws of thermodynamics dictate that energy cannot be created from nothing, only converted from one form to another. In this case, the initial spin requires energy input, and losses due to friction and resistance prevent indefinite operation. While the generator can produce some electricity, it doesn't generate free energy as some proponents claim. However, the experiment isn't without merit. It demonstrates basic principles of electromagnetism in a hands-on way. For those interested in renewable energy, building a Magmo generator is an educational exercise, if not a practical solution. The real value lies in understanding the challenges of energy generation and the importance of efficiency. Could future advancements in materials or design make Magmo generators more viable? Perhaps, but for now they remain a fascinating yet impractical DIY project for energy enthusiasts. If you're looking for reliable home power, solar panels or wind turbines are far more dependable alternatives. Still, the Magmo Generator sparks curiosity and inspires innovation, which is essential for progress in sustainable energy. The quest for free energy continues, and while this experiment may not have cracked the code, it brings us one step closer. The moment of truth arrives as the DIY Magmo Generator sits ready for its first real-world test. A flick of the switch sends the rotor spinning, its magnets whirling past the copper coils in a rhythmic dance. A multimeter hooked to the output terminals flickers to life, displaying a modest voltage reading, proof that the concept works. But the real question remains, can this tiny device generate enough power to be useful? Or is it just a scientific curiosity? Initial measurements show an output of around 3 to 5 volts, enough to light a small LED, but far from household levels. Connecting a rechargeable battery reveals another challenge. The generator struggles to maintain consistent current over time. Friction, heat loss, and minor misalignments all contribute to energy drain, limiting efficiency. A small desk fan is attached to the output, and while the blades twitch, they never achieve full rotation. This confirms what physics already dictates. Energy cannot be created, only converted, and losses are inevitable. Yet, the experiment isn't a complete failure. It proves that electromagnetic induction can produce electricity from motion. The next step is optimizing the design to squeeze out every possible watt of usable power. Larger neodymium magnets are installed, their stronger fields inducing higher voltage in the copper coils. The rotor is rebalanced to minimize wobble, reducing mechanical resistance that saps energy. Thicker gauge wiring is used to lower resistance, ensuring more current reaches the output. After these adjustments, the multimeter now reads 7 volts. An improvement, but still not enough for practical use. A small USB charger is connected, but the current remains too weak to charge even a low-power device. This exposes the harsh reality. Scaling up a DIY Magmo generator to power a home is nearly impossible with current materials. Commercial generators use precisely engineered components and external energy inputs, like steam or fuel, to sustain output. The Magmo generator, in contrast, relies solely on initial momentum and magnetic fields. A self-sustaining loop remains theoretical. Overheating becomes an issue after prolonged use, as electrical resistance turns wasted energy into heat. Safety checks confirm no dangerous voltage spikes, but the risk of burns from hot components is real. After an hour of testing, the output drops further as the rotor slows, proof that perpetual motion is still a myth. Disconnecting the load allows the rotor to spin freely again, but without a continuous energy input, it eventually stops. This experiment highlights the gap between theoretical free energy and real-world practicality. Could a larger professionally built version overcome these limitations? Perhaps, but the cost and complexity would likely outweigh the benefits compared to solar or wind systems. For now, the Magmo generator remains an educational demonstration of electromagnetic principles. It's a fun project for hobbyists, but not a replacement for grid power or established renewables. Still, the knowledge gained could inspire future innovations in energy harvesting. What if multiple small generators were linked together? A test with 2 units shows slight gains, but synchronization issues introduce new inefficiencies. The pursuit of free energy is filled with such trade-offs. Each tweak solves one problem but often creates another. Despite its limitations, the Magmo generator sparks important conversations about energy independence. It reminds us that while breakthroughs are rare, experimentation is essential for progress. For those determined to keep tinkering, the next step could be integrating solar assistance to sustain rotation. Hybrid systems combining multiple energy sources might bridge the gap between DIY dreams and reality. Until then, the Magmo generator stands as a testament to human ingenuity, even if it can't power a home yet. What improvements would you try to boost its output? Could this technology evolve into something more practical in the future? Share your ideas. Every great invention started as an experiment. What are your thoughts on DIY energy solutions? Have you tried building a Magmo generator or similar device? Share your experiences and ideas. The future of energy might just come from grassroots innovation.